Hey everyone, I am Kanay Gupta and today I am going to show you how to solve array manipulation HackerRank problem. So let's go through the problem description. Starting with a one index array of zeros and a list of operations. For each operations, add a value to each of the array element between two given indices inclusively. Once all operations have been performed, return the maximum value in your array. For example, the length of your array of zeros n equals to 10, where 10 is the size of the array. Your list of queries is as follows, and you will get the queries in terms of a, b, and k. So add value of k between the indices a and b inclusive. So let's see guys what it means. So here is mentioned n equals to 10. It means we have an array of 10 elements. So it's mentioned 1 to 10. And we have given a queries in that we have a, b and k. So we have to add the k value between the indices a and b inclusively. So if you see, a is 1, b is 5 and k is 3. So we have to add 3 from 1 to 5. So we are going to add 3 from between range 1 to 5. So you can see from 1 to 5 we have added 3. Then next query we have to add 7 from range 4 to 8. So you can see this is a 4 and this is 8. So we have to add 7 from 4 to 8. So once you add 7 and 3, it will become 10. Here also if you add 7, it will become 10, and if you add 7 and 0, it will be 7 and 7. In the next query, we have to add 1 from 6 to 9. So you can see from 6 to 9, we have to add 1. So if you add 1 and 7, it will become 8. Like that, similar, right? Once you have performed all the queries, this is the final result you will get. And after that, you have to return the maximum value from this array. So if you go through the array, you will find the maximum value in this array is 10. So in this case, the answer will be 10. So this is what problem statement guys. You have given an array and you have given a certain set of queries and you have to add k element between the indexes a and b inclusively. And after performing all the queries, what is the final array you have to return the max value from that. Let's see the input format. So in input, you will get n and m, where n stands for size of the array and m stands for number of queries. So you can see the default size of the array will be 5. So there will be 5 elements. And the number of queries, we have 3 here. In each query, we have 3 integers. First is a, second is b, and the third is k. A and b are the indices of the range, and k is the element which we are going to add. Let's take the same example and try to build the logic around. This is the sample input guys. And here, first I will show you what we are going to achieve. So this is the n, this is the m, and this is a, b, and k. So n is the number of elements which will be present in the array, and by default in starting all will be 0. So you can take 3, 4, 5. So there will be 5 elements in the array and all will be 0. So the first query will be, you have to add k 100 from between index 1 to 2. All are inclusive. So you have to add 100. So if you add 100, so it will be 100. If you add 100 here, it will be 100. So after first query, result will be this. Now if you talk about the second query, you have to add 100 from range 2 to 5. 2 to 5. So in 2 already 100 is there. You have to add one more 100. So if you add 100, so it will be 200. You have to add that 100 2 to 5, right? So everywhere you have to add 100. So if you add 100 here, it will be 100. If you add 100 and 0, 100. If you add 100 here, so it will be 100. So in the final query, you have to add 100 from 3 to 4. So 3 to 4, you have to add 100. It means third and fourth you have to add 100, so it will be 200. It will be 200 and rest will remain the same. So we'll just put that. It's up to you guys how you are adding, because I'm just going to show you what we are going to achieve it. So once you perform all the queries, finally this is the array which you have got. Now your task is to return the maximum from this array. So if you traverse this array, you will find the maximum element is 200. That will be your answer. So this is what we have to achieve. We have given a number of input which should be present in the array and the number of queries which we need to handle. And after performing n queries, what will be the maximum result from this array? I hope guys now this problem is clear to you. Now we'll see what are the challenges while solving this problem. Normally, what people do, let's try brute force approach. To solve this problem, first we have to take an array. So I am initializing the array with n plus 1 size. In Java, array starts from the 0 index onwards. So that's why I have taken an n plus 1. Because for every indices, I don't want to do minus 1. You can see in the question they are starting from the 1. But in Java, array starts from 0 index onwards. So I need one element extra in that. Or otherwise I need to do minus 1 for every indices, for every query. Which I don't want to do. I want to make it simple. So I have taken an array of n plus 1, n, and indices start from like this to n. Then you will run a for loop between range a to b, because you want to add a to b the 100 quantity or k. So you will add by using this you can add the k element into the range from a to b. Just think about it. How long it will take k element from a to b? In worst case, there is a possibility you are going to end up from adding k from here to up to the end. If there is a range of 1 to n, 1 to 5, right? So at max, this loop will go up to n times. So the complexity for adding this element will be on. In the worst case, there is a chances you are going to add k to the whole array, and the complexity of adding that element will be on. And how many queries you have? You have m number of queries. For each query, if you are taking on time to adding the element, then for m number of queries, you will take n into m time. So the complexity of your solution is ONN. And after that, you are going to find out the maximum element from the array. And to get the maximum element from the array, the complexity will be ON. So the overall complexity of the solution will be NM plus ON. So overall complexity of your solution will be n into m. And if you apply this logic and submit your code in a HackerRank platform, this is not going to work out. You will get time limit exceeded error. I hope most of the guys you have already tried this, but if you have not tried this, I will suggest you just see what you will get. This is how you will learn. So just see what you will get. So if you use this algorithm, you are not able to pass all your test cases. So if the error is time limit exceeded, it means we have to do something better than this. We have to optimize our code. So is there any possibility we can optimize this code? Yes, step. Now we have to find out a solution which should be more efficient than n cross m. But how will you find it? How we can come to know where we should optimize our code? If you're given a 4 options and you know the right answer, then you know the right answer. But sometimes, if you don't know the right answer, what you try to do? You just try to check what cannot be the right answer. Right? So if you eliminate, basically this is called elimination method. You have to eliminate the options which you know cannot be optimized. So you have to use either one of the approach. If you know where to optimize the code, just go and optimize it. If you are not sure where to optimize, use this elimination method. Think where you can't optimize at all. Just discard that, which I am going to show you how. So now one thing is for sure, I need to reduce the time complexity of my solution from O(n)m to something else, which is lesser than this. But how I'll come to know where should I do? To find out where we can do the optimization, there are two things. Either we are already sure or know where we have to do the optimization. But if we don't know, then we can use the elimination method. It means we will discard all those points where the optimization cannot be done at all. Like our overall complexity is O(n)m. So here we are discarding O(n). And we know O(n) is time complexity for getting the maximum. So we know it doesn't make sense to optimize this code because anyhow this complexity is there. So you have to find out to reduce this, not this. You have to work on this part. It means how it's coming O(n)m because of n queries, and we are taking for every query is n time. So where is the possibility? See, we cannot do anything. If we have n queries, we have to process the n queries. In that we cannot modify from ourselves that okay, don't process n queries. I am going to process only some queries, 1 or 2 queries. It's not like that. So at the end we are going to process n queries. So we cannot reduce anything here. So then where we can reduce? Then the second thing is this part. If you cannot reduce m, you know m will be there. Is there any chances we can reduce O(n) time complexity to something else? Why we are getting O(n) time complexity? Because at max there's a possibility we can get range from 0 to n or 1 to n. So we are going to end up adding k to all those elements. So can we do something better to add k element between a range? Yes, we can do. Suppose I have an array of 6 elements, index from 0 to 5. If we have query something like this. One solution we know, we will run a loop from 1 to 4 and add 1. But now I am going to tell you the alternate way of doing. I am just going to add 1 at first. So I have added first. That's it. But we have to add 1 from 1 to 4. But what I will do, I will add only at starting place. If I apply some algorithm on this array, then see what we'll get. I hope you remember guys what is prefix sum algorithm. If not, then please check out my tutorial on top right corner and come back to this. So it will be easy for you to understand. So what is the prefix sum algorithm? Just add the element, previous element plus current element. So 0, previous element plus current element, 1, previous element plus current element, 1, like that. If you keep on adding, so you will find this is the array. And you can see here now 1 is added. Here we ask for add 1 from 1 to 4. But here one problem we have. The 1 is added from 1 to 5 indices. We have 5 indices, right? 0, 1, 2, 3, 4, 5. We ask you to add 1 from 1 to 4, but by mistake we have added 1 to 5. To remove this side effect, what we can do, if they ask us to add 1 from 1 index, we have added 1. And we know we have to add up to 4. So what we can do, instead of this, we will add 1 at here and subtract 1 after b plus 1 means 5th index. So this is the index. So why we have subtracted 1 here in 5th index? Because now if you apply prefix sum algorithm, it will not give the side effect. Let's see how. Now if you apply the prefix sum algorithm on this, see what happens. previous element plus current element 1, previous element plus current element 1, previous element plus current element, previous element, current element, previous element plus current element. So now you can see we have to add 1 from 1 to 4. So now 1 is added from 1 to 4. Now here we got 0. Previously, if we are taking the index and adding 1, and after applying prefix sum algorithm, this effect will be keep on continue till the end of the array. But we have B index here, which tells us you have to keep this effect continue, or you have to add this k element up to 4th index. So from 5th index onward, you don't have to change any content. To just negate this fact, what we are doing, we are just going to B plus 1 index, which is 5th here, and adding minus quantity of this. Because once we apply the prefix sum algorithm, it will add the same element to this element. So to negate that effect, we have to subtract that element with the same quantity, means k. So if you are going to add k element and we have already subtracted the k element, so it will not affect further on. I hope guys you are getting this. Let's do something more so it will be clear. But before that, I would like to tell you how we are going to update this array. So instead of adding all the elements in a for loop from A to B, what we are going to do, we are going to update the element using A and B indices. We are going to add the element in array at A index. So we are going to add whatever the element was there plus k. So we are going to add this element k to the same index where we have added. But at the same time, we are also going to add minus k on B plus 1 index. So in B plus 1 index, we are going to add minus k. This statement will add the element, and the effect, once you apply the prefix sum algorithm, that effect will be continued till the end. And this statement will take care of that effect should not go beyond the B last indices. So by using this statement, we are negating that effect. So these 2 points you have to remember, guys. If it's not clear, just bear with me. I will just do the same thing in front of you so that you can see how it works. Now I am going to apply the same logic in the sample input. Let's see how it works. So now I have taken an array of 5. As I said, I am going to take the array of n plus 1, which is 6 element. So I have taken a 6 element. Now I am going to perform each and every query in front of you, and you can see the result. Just I wanted to show you, I'll do this in front of you parallelly by using both the approaches, and you can see there's no effect at all. First, I am going to use the brute force approach. So this is the brute force solution, which is O n into m. So I am using these queries. So what will be the result? After first query, array will look something like this. 1 to 2 we are going to 100. So you can see 1 to 2 we are going to add 100. So first query we have made. After second query, we are going to add 100 from 2 to 5. So from 2 to 5 we have to add 100. Now first final and last query, add 100 from 3 to 4. So this is the final array, guys, and now we have to come up with a maximum number from this array. So if you traverse this array and get the maximum, which will be 200. 200 is the answer. Now I'll apply the optimal solution by using prefix sum algorithm. So this is the same array, guys. So I'm going to perform the first query. So once you do the first query, just for easiness, so after applying the first query, A is there, means go to element 1 and increase that element by 100. Go to element 2 plus 1. If you remember, guys, I showed you two statements. If you add element at starting index, the effect will be continued till the end. But we have to stop this effect after 2, because 1 and 2 is inclusive, so that effect should be applicable from 1 to 2. After that we have to negate this effect. So I am going to index 2 plus 1, which is 3, and do minus k, which is 100. How much time it will take? Because every time I need to just update 2 indices, so it will take constant time, O1 time to do it, and rest will remain the same. So I'll put the same, rest will be. So did I apply any for loop here? No, because every element was 0. I just used 2 indices and used 2 statement to update these 2 indices. Now I'll apply the second query. What was the second query? You have to add 100 from 2 to 5. I am going to add the 100 2 to 5. So what I need to do? I need to go to 2 index, add the 100, and go to the 5 plus 1 6 index and minus the 100. 5 plus 1 6. We don't have 6 index here because 5 is the last one. Here I just wanted to tell you, if you want, you can take a index n plus 2 size. You can take an index of n plus 2 size to see how his value is getting changed after this. Or if you want, instead of a, like here, if you can see, I am using direct a index here. You can use a minus 1, so that because array index starts from 0 onwards, I have taken a 1 extra element, and you know that you are going to deal with only the 5 element, 1 to 5. So you don't need extra element, but I just wanted to show you how it will work. So suppose I have taken a 6 element. So if you do 5 plus 1, 6, index out of bound exception you will get. So this is the reason, if you are using this approach, you have to take n plus 2 size. So instead of array of size 6, just take array of size 7. So let me just modify this. So now this array is of size 7. So now we have to add 100 to the 2 we have added in second index, and minus 100 to the 5 plus 1 6 index. So we are adding minus 100 in this. Rest will remain the same. So whatever was there, I am not changing anything. I am just modifying it only 2 indices. Basically 2 and 5 plus 1 6. So I am just highlighting that what I have modified. And first I have modified this and this. In the second query I modified 2 and this. Now I move on to the third query. We have to add 100 from 3 to 4. So I'll go to the third index and add 100. So whatever was there, if I'll add 100, it will become 0. In 4 plus 1, we have to do minus 100. 4 plus 1, which is 5 minus 100. So if I'll do add minus 100, and rest will remain the same. So you can see guys, rest elements are same. So here I have modified only third index and fifth index. So only 2 places I am doing the changes, at A and B plus 1. This is A, basically this is mentioned, and B plus 1. So left side is A and right side is B plus 1. Once the operations are finished, now I am going to apply the prefix sum algorithm, because I want this final result. You can see there are differences. This result is totally different from this. So to get this final result, I am going to apply prefix sum algorithm. So once you apply prefix sum algorithm, so now you see guys, these two array. Don't you think both are same? Right? Just we have an extra element. Why? Because we have taken an extra indices. Why I have taken extra indices? Because I don't want array index out of bound exceptions. Either you need to deal that condition explicitly, or you can just take one element extra. So you can see after applying that algorithm, I am able to get this. And after that, what we have to do? We have to just take a max of this, and max of this will be 200. It will be same, right? Because here also we have the same array, here also we have a same array. So max from both the array will be 200. So it's the same thing guys, but what will be the complexity of the solution? Let's see. If you can think here, previously if there is a suppose query like 1 to 5, so we are going to add 100 to 1 to 5 up to n element, right? At worst case. So the complexity for each query was OM. But in our case, every time we are only updating 2 indices. not all. So to update the indices in array, it will take O1 time. So for each query, we are taking O1 time. So now we have a M query. So how much time it will take? It will take OM time to perform M queries, right? And to get the maximum out of this array, it requires ON time. So the overall complexity of this solution will be OM plus ON, or we can say N plus M. So the overall complexity of this solution is ON plus M, which is a huge improvement from N into M. So now if you apply this logic and submit this code on HackerRank, it will definitely work. Let's see the algorithm in action, guys. So this is the function name, guys, which is already given in a HackerRank platform. There are two inputs. N is the size of the array which we have to take, and these are the queries which is given in the 2D form. So I have taken one output array. So in that, as I said, I am taking an array with n plus 2 size. I told you, right, guys, why I have taken an n plus 2 size? Because in Java, array starts from 0 indices. So I don't want to modify each and every indices. So it's up to you guys. You can take n also, but every time you have to manage the index manually. So this is the array I have taken, and these are the query. So I am looping through this query. What are the queries there? So we have m queries, so m times this loop will go, and extracting the three params or three inputs a, b and k, because we should have to know what is our left range, what is our starting and end range, and what is the element we are going to add. As I said, I showed you two statements, if you remember. We are going to add that element to the A, so we are going to add that element to the A, and at the same time we are going to subtract that element to the B plus 1. So I am subtracting that element from the B plus 1. So after performing all the queries, I am just passing this array to a function which is a getMax. So in that I am going to return the maximum element. This logic will only just update the array, nothing else. But in getMax, I am applying the prefixsum algorithm. So let's see the getMax, what we are going to do. We are taking the same array and traversing each and every element, but at the same time we are applying the prefixsum algorithm. What prefixsum algorithm says? Take the previous sum, take the previous element plus current element. So every time I am taking that element plus current element and checking. At the same time I am checking also whether it's a max element or not. If it's a max element, I am storing it. Once this loop got over, we will be having maximum element in the max variable, and I am returning them. Let's copy this code and run on HackerRank platform. So I am just pasting my code here, and I will run this code. So sample test case got passed. Let me submit my code. I hope, guys, this problem is clear to you. How we have reduced the time complexity of our solution from ONM to ON plus M, which is a huge improvement. If you have any better approach, guys, please let me know in the comment section. And if you need the source code, you can go to my GitHub repository and download the source code from there. Thanks for watching, guys. Keep rocking.